All right, we are going to go over questions 1 through 10 on the EOC practice test, part 1. Okay, this is for those of you that have been absent and missed the lesson in class, or you maybe just didn't get to write everything down, okay? So I have to switch between tabs, between the workspace and the test questions. All right, so number 1 asks us to define a rational number and an irrational number. A rational number is all positive and negative numbers and 0 that can be written as a ratio or fraction. An irrational number is a number that cannot be expressed as a ratio or a fraction and is not an imaginary number. Okay, sorry about my handwriting, guys, but you know how it is when I use this tablet. Give an example of each. So rational is all whole numbers. Integers. Fractions. And terminating decimals. I'm going to write the irrational numbers up here, the examples. So an irrational number would be pi. Any square root that's not a perfect square root, like square root of 11, negative square root of 8, and any repeating decimal, any decimal that does not stop. Discuss the possibilities for the product of two irrational numbers. The product of two irrational numbers is sometimes irrational. The sum, discuss what happens when you sum a rational and an irrational number. When you add together a rational and an irrational number, the sum will always be irrational. So sum of rational and irrational is always irrational. All right, so now that we have that, we're going to come over here to our practice questions, or to the questions, and we will see that number 1 asks us which statement is not always true. And we can flip back and forth between this and the other page. So A says the sum of a rational number and an irrational number is irrational. The sum of a rational and irrational is always irrational. That is always. It's asking what is not always true. So we're going to eliminate A. Go ahead and log into Performance Matters. Log into Performance Matters. Or you want to study first? Okay. The sum of 2 rational numbers is rational. So that's the same for sum and product, okay? The sum of 2 rational numbers is rational. The product of 2 rational numbers is rational, and that is always. So we can eliminate B and D. For C, the product of 2 irrational numbers is irrational. That is not always true. Come back and look over here. The product of 2 irrational numbers is sometimes irrational. You can multiply 2 irrational numbers together, and it is possible to get a rational number. So C is not always true. I am going to switch to red because you guys are supposed to be using red pen. For the second one, you should be doing this in red pen or on a different piece of paper or something so I can see the difference. Number 2, define polynomial and be specific. So polynomial is an expression of more than two algebraic terms, especially the sum of several terms that contain different powers of the same variable. Okay, I'm going to write on here also no division by variables. No fractional exponents. No negative exponents. Okay, and then 2 non-examples. We've got 3x, y to the power of -2, 2 divided by x plus 2, 3x, y to the power of 1/2. Okay, those 3 are not polynomials. So now come back over here to the questions, and it's asking you to choose the missing exponent to create a polynomial, and they try to trick you. You need to notice that there is a negative right there. Okay, so because there is a negative right there, we need to get rid of that negative. And the only way to get rid of the negative is to add another negative and make it a double negative makes a positive. Okay. So the only option that we have is C, -9, because that would turn into a +9. Number 3, they want us to write the following radical with rational exponents. So this is where we are going to use Tybo and obit. Top in, bottom out, out, bottom, in, top. So Tybo is when you have, say, a variable and a fractional exponent. Obit is when you have a radical with numbers inside. Okay, so the way that I remember is if I look at it and I have a number out here on the outside, not letting me highlight. Well, if I have a number out here on the outside, I see the outside first. So if outside is first, then I'm going to use obit because out is first. So out, bottom, in, top. So I'm going to write my bases first. I have A, M, P, out, bottom. So now I'm going to draw fraction lines. I'm going to put that outside number on the bottom. Out, bottom, in, top. So now I'm going to take those inside numbers and I'm going to put them on the top. There's an invisible 1 here. When I look at this, I see M 10/5 can be simplified. So I'm going to say A 3/5, M squared, P 1/5. And that's it. That's your answer. Now I'm going to come over here and it asks which of the following expressions is equivalent to the radical expression. Same thing. I see an outside number first, so I know I'm going to use obit. Out, bottom, in, top. Write your bases. M, N. Draw your fraction lines. Out, bottom, in, top. If you look at this, you only have one choice that matches that, and we could have stopped when we put the outside number on the bottom, because the only one that has 3s on the bottom of the fractions is A. Yep, didn't mean to do that, but A is the answer. Number 4. They want us to give an example of the associative property of addition. So the way that I explain the associative property is like you have a group of friends at school, you have a group of friends at work, you have a group of friends at church, you have a group of friends in the neighborhood, but they're not all really your friends. They're kind of like your associates, okay? So the associative property of addition has to do with groups. Groups of associates. Or I should say, not just groups, but grouping, the way that you group it, grouping. And I'm going to say order does not change. So an example of the associative property of addition is if you group together A plus B, and then have C over here by itself, it will still equal the same thing as if A was by itself and then you group together B plus C. Associative property of multiplication is the same thing. Group together A times B times C by itself. You will get the same product as A by itself and grouping together B and C. Communitive property of addition is just like Commutative is like communication, okay? Sometimes you guys don't understand what I say the first time I say it, so I just switch a couple things around, and when I just switch a couple things around, all of a sudden it makes sense and you understand it. So commutative is the order that you say things, or the order that things are done, order. So that says A plus B is the same exact thing as B plus A. 2 plus 3 is the same as 3 plus 2. And an example of the commutative property of multiplication, same thing. A times B is the same thing as B times A. Give me just a second, guys. I gotta stop sharing my screen for a second. Okay, sorry about that. I'm back. All right, so now we have done the associative property of addition and multiplication and the commutative property of addition and multiplication. Now we're going to come over here. We are going to look at number 4. It asks which of the following shows an equivalent expression to 5 times 3 times 12 if only the associative property was used. So associative property has to do with grouping. Order doesn't change, so you can simply look at this and see 5 times 3 times 12. Come down here and look for 5, 3, and 12 in the same order. And if you look, 5, 3, 12, 5, 12, 3, 3, 5, 12, 12, 3, 5. The only one that is in the same order is A. So your answer is going to be A. Number 5, 6, 7, and 8 all go together on the workspace. Okay, multiplication property of equality. So for all of these, A is going to equal B. All of them, same thing, A equals B. Means A and B are the same value. Okay, so for the multiplication property of equality, if A and B are the same value, then A times C is the same exact thing as B times C, same value. Division, same thing. A divided by C is the same thing as B divided by C. Addition, A plus C is the same thing as B plus C. Subtraction, A minus C equals B minus C, same thing. And then the distributive, if A and B are real numbers, then A times B plus C is the same thing as A times B equals B times, I'm sorry, Nope, back up. That's wrong. A times B. Yeah, let me start over. That bell threw me off. A times B plus C is the same thing as A times B plus A times C. Okay, so all they did there was they just, you guys are used to distributing. That's all they did. They took that A, distributed it to B, got A times B plus A times C. Same thing, just written out differently. So now we come down here to 5, 6, 7, and 8, and they're going to ask us about those properties of equality that we just did. So for number 5, they want to know, how did they get to step 1? From 4x minus 7 equals 2x minus 6. How did they get from that to 4x minus 28 equals 2x minus 6? So what they did was they distributed the 4 and they got 4x minus 28. So that is the distributive property. Number 6, they want to know, how did we get from step 1 to step 2? So step 1 says 4x minus 28 equals 2x minus 6. Step 2 is 2x minus 28 equals negative 6. So they got rid of the 2x here. Have a good day. They got rid of the 2x here by subtracting it from both sides. They got rid of the smallest variable. So that is the subtraction property of equality. Number 7, to get from step 2 to step 3, you can see they got rid of the negative 28. They got rid of the negative 28 by adding 28 to both sides. So that is the addition property of equality. And then number 8, to get from step 3 to step 4, you can see they got rid of the 2. They got rid of the 2 by dividing both sides by 2. So that is division. Come back over here. Let's do number 9. Define the real number system. So the real number system includes any number on a number line, positive, negative, or 0, whole numbers, rational, and irrational. Define all positive rational numbers. So all positive rational numbers, the numerator and denominator are both positive or both negative. All positive integers less than 30, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, every single number through 30. all multiples of 25 less than 200, you have 25, 50, 75, 100, 125, 150, 175, and I'm going to stop there because it says less than 200. Now come over here to our question for number 9. And it asks us about a local drive-in theater that sells entrance tickets for cars on weekend nights. At capacity, the drive-in can hold 72 cars. The function C of n equals 25n represents the drive-in's revenue on a weekend night, where n represents the number of cars. In this situation, what is the domain? So remember, the domain are x values. In this case, x is n because it tells us n. Our variable here is n. Okay, so it's our n values. They say n represents the number of cars. Number of cars. Tells you it can hold up to or equal to 72. So n is going to have to be less than or equal to 72. So does that mean our domain, now let's go back and see, it's asking us what is our domain. Can our domain be all real numbers? Well, all real numbers includes the number a million. Can that drive-in hold a million cars? No, it cannot. So eliminate A. All positive rational numbers. Again, million is a rational positive number. Can the drive-in hold a million cars? No, it cannot. All positive integers less than or equal to 72. Well, look, we put up here, if n was less than or equal to 72, then that works. So that is our domain. And just to make sure, all positive integers that are multiples of 25, well, you can see over here on the workspace, all multiples of 25, we only did up to 200. Even then, sorry, I'm trying to erase and it's not erasing. 125 is a multiple of 25, but 125 is greater than 72. The drive-in cannot hold 175 cars, so that is not an option. Number 10, which is going to be the last one for this video. They want us to write the formula for the area of a rectangle. The area of a rectangle is A equals length times width. Draw a rectangle with one side of x plus 3 and one of x minus 8. So they just had us set up the box method. You can cut that into 4 and we can solve. So x times x is x squared. X times 3 is 3x. Negative 8 times x is negative 8x. Negative 8 times 3 is negative 24. Okay, this doesn't let me highlight like it does with the tablet, but remember we can combine all of our like terms diagonally. So, or pull them all out diagonally. So we're going to have x squared, 3, positive 3 and negative 8 is negative 5x, and then negative 24. Minus 24. So if we come over to our test questions, a square has sides of length s. A rectangle is 6 inches shorter. So I'm going to draw a rectangle and I'm going to label both of my sides s. But it says one side is 6 inches shorter. So I'm going to subtract 6 and one side is 1 inch longer. So I'm going to add 1. Again, they just had us set up the box method. S times S is S squared. S times -6 is -6S. 1 times S is just S, but if you want, you can put that 1 there. Just remember it's invisible. 1 times -6 is -6. Combine your terms diagonally, you get S squared. -6 plus 1 is minus 5S, and then minus 6. There's your polynomial that represents the area of the rectangle. That is the same thing as C. S squared minus 5S minus 6. All right, that's going to be it for this video. I don't want to keep you guys too long. I will do the next 10 on the next video. See ya.